So the last video was probably cut off a bit short, but I think we got to this point where we figured out how to replace the geometric sum in the denominator. So this means that we are able to calculate C as 1000 multiplied by I divided by 1 minus v to the 10th multiplied by, so this is all in the denominator here, multiplied by 1/3 plus 2/3 times v to the 10th plus v to the 20th. Now let's try to implement that inside a fancy calculator of some sort. You can also do this in R or just in Google, whatever you fancy. But here we have that the interest is 0.04, so 4%, and, oh, oops, that was something else. And let's just call this I for interest. Well, that doesn't really work out that well. Let's just call this interest. And the discount factor is then given by 1 over 1 plus interest, right? And let's just give this the name discount factor, V. I think I've already written it here. So also, now we can find C. And C by our formula is 1000 multiplied by the interest divided by 1, so we have 1 minus v to the 10th multiplied by 1/3 plus 2/3 plus multiplied by v to the 10th plus v to the 20th. Great. And I need my equal sign. There we go. So C is equal to 99.42. And the thing is, now we can kind of try to ask ourselves. Now we figured out what C is. So what's going to go on is the first 10 years you pay around 33 units per year. And then the next 10 years you pay around 66 units per year. And then the last 10 years, you pay around 100 units per year. And that seems like an awful amount of money you have to pay back in order to get 1000 in your hands today. So very rightfully, he asks this question: after your 10th payment, will you owe more or less than 1000? So will you owe more or less than 1000 after your 10th payment? Well, let's take a look. How much do we owe after our 10th payment? If we stand at our 10th payment, which is right after our 10th payment, that's here, and we look into the future, then we will need to calculate the present value at time 10 of the future payments. And let's try to calculate that. I'll just take a copy of this for farther below. So because we've already done the whole count and discount thing, let's try to do this using some more actuarial notation. So at this time, if we set time 10 as our new null point, then how can we look at this? B. Well, then we stand at time 10 and then we discount everything back to this time. So if we stand at time 10 and look into the future, what we see is, first of all, an annuity in arrear that spans 10 years. So at time 10, the present value of that would be, well, let's see, V of 10 would be equal to the present value of an annuity in arrear that spans 10 years. So that would be 2/3 times C multiplied by A and then 10 down here. And if we look at the payments that come the 10 years afterwards, well, that's just a deferred annuity in arrear. And that's an annuity that has been deferred for 10 years. So that looks like this. You may also just do this completely the same way as before, where you say, I discount this 1 year, discount this 2 years, but you will just arrive at the same result. So this is just to get you acquainted with the actuarial notation. And what we have here now is we can take some stuff outside of a parenthesis. So this is equal to C multiplied by A10, because since we know from the book that a deferred annuity in arrear has a present value that may be symbolized by the present value of the annuity in arrear over the same payment period, and then multiplied by a discount factor V to the K, then we may take a 10 outside of this and then have V to the K left inside. So I have multiplied by 2/3, that's from the first term, plus, and then from the second term, I have V to the K left. So think a bit about this. Good brain exercise. If you're a bit confused about this, just look at it a bit more. So here I have that what I have left after the first 10 years is this. And recalling that the present value of an annuity in arrear, this A10, well, how do I write it formula-wise? Well, it is the same as the sum of discount factors for V to the S, or for V to the S, where S goes from 1 to 10. And that is again the same as 1 minus V to the 10 divided by I. Well, then we just have C multiplied by 1 minus V to the 10 divided by I multiplied by 2/3 plus V to the K. So the amount I owe after time 10 is given by this thing here. Now we go into trusty Excel and try to figure out what this number is. So this is equal to the value of C multiplied by 1 minus V to the 10 divided by the interest, and then multiplied by 2/3 plus V to the K. And what my K is in this case is it's 10, right? Because I have deferred the last 10 payments 10 years. So that was 10 here. I should just correct that. Here we go. And what we see is the amount that's owed after 10 years is actually 1,082. Wow. So that is equal to 1,082. And that's greater than 1,000. And what can we see from that? Well, that is, if I need these 1,000 kroners in the beginning of this 30-year period, then I end up just paying loads of money back in interest because I pay the loan back so slowly. So the question is it really preferable to have this kind of contract where after the first 10 years, the amount you actually owe is even more than the amount you borrowed, even after you've been paying back your loan for some time? And the question here is actually, well, the answer is actually kind of, it depends on your interest in some weird way. Because if you had a lower interest, if it was cheaper to borrow the money, let's say if it was 2%, well, then maybe it wouldn't be that bad. Or if it was even cheaper, then it wouldn't be that bad at all. So it really depends on the interest in some cases. And if you can find somewhere where it's cheap to borrow the money, then it might be that this thing might actually work.